review of index law and negative indices. Okay, I'll focus on the negative indices. This is the harder topic. Okay, this is the harder topic. First of all, we have a couple of laws here. The first law is when you have like two numbers with the same base but different power, what you do is you add the power together. Okay, when you times two numbers, they have the same base but different power, you will add the power. The second one is when they have the same base, you divide them, you will subtract the power. You will subtract the power. When you have a number with a power and you want to power the whole thing again, you will times the two power together. Okay, you times the two power together. And it's very special one is the zero power. So a to the power of 0, any number except 0 to the power of 0, that equals to 1. So anything to the power of 0 will be 1 except 0. So 0, 0 has no meaning and does not exist. Okay, you don't have this. When you put that into the calculator, it will give you undefined or error or something like that. So you don't have 0 over 0. Okay, next law is when you times two number and then power the product, you will have like power one number times power the other number. So similarly, you have the division version. You have a divided by b to the power of m. You have a to the power of m divided by b to the power of m, which you need to make sure b is not equals to 0 because denominator can't be 0. Because denominator can't be 0. Okay, one thing you need to be aware of, like a minus b to the power of m is not a to the power of m minus b to the power of m. Do not confuse with law 2 and law 4 or law 1 and law 4. Law 2, law 5 and law 1 and law 4. They look similar, but they're not talking about the same thing. Just give you the easiest example. If you have a minus b to the power of 2, that is definitely not equals to a to the power of 2 minus b to the power of 2. It's definitely not that. Okay, it's definitely not that. That's a squared plus b squared and minus 2ab, so they're not the same thing. Okay, my emphasis will be the negative indices. Well, a lot of students don't know what the negative means, like don't know what to do with the negative power. When there's a negative power, means it's a reciprocal. Okay, it's the reciprocal. So what you will do is you just hide the negative, you just write a to the power of m, and that's the reciprocal of that. The negative power means the reciprocal of a number. You can't, well, when I teach year 10, like 2 years ago, I think a lot of students put the negative into the front. You can't believe it. Like, you just like, when you go through, oh, this should be the reciprocal. Okay, they remember, they do the right thing, they do practice, and after they do the test, and I think it's under pressure, automatically get the negative sign into the front. That become a minus a to the power of m. And that's definitely not right. So just pay a little bit attention on this one. Negative power, it actually means the reciprocal of that number without the negative. So that's the basic rule. Okay, that's the basic rule. So, well, just choose one example from, okay, I'll show you one example here. Let me find that. Okay, let's have a look at the zero power first. Let's have a look at zero power first. Example 6. Example 6, this question here. This one will give us s to the power of 6 because that's two power and another power. You times the power together and times 5. Okay, r to the power of 0, which is 1, and then to the power of 3. Okay, 1 to the power of n will always be 1. Okay, 1 to the power of n will always be 1. N can be anything. Okay, 1 to the power of n can be 1. Times rs squared. So this is the number, that's a 5. And then you write that in the alphabetical order. The next is r. So we just have one r. And we count how many s are there. There are 8 s. So it's 5 rs to the power of 8. Okay, 5rs to the power of 8. When you times the number with the same base, you will add the power together. I think most of them are very easy. It's just for easy practice. I just want to have a look at the special ones. Okay, there's a special one. Can't find it. Okay, here, example 16. Okay, it's the negative. I want to practice more about the negative. The normal one, I believe you can do it, or you can just look at the rule and figure it out. But the negative one is quite tricky. Okay, let's have a look at 16. When you have a fraction and you have negative power on top or bottom, you can very easily do that by swap the place. For example, there's a -5, right? So I'll still write a fraction here. It's the reciprocal. Okay, it's the reciprocal. When you have 5 to the power of -1, because it's negative, which means it shouldn't be on the numerator, you will directly put that on the denominator with the same power to get rid of the negative. And then h to the power of 3, so that one just stay there, okay, because it's a positive power. And then k to the power of -2, which shouldn't be here, so you will have k to the power of 2. Make it to the bottom and just still have the same size. And then we have 4 to the power of -1, which means shouldn't be the denominator, so you will times 4 onto the top. Just swap it. And then m to the power of -2, you will go for m to the power of 2. And this p here is perfect fine, so you just times the p, make the p stay there. So what you have is just 4h3m2 over 5k2 times p. So when you meet the negative power, you just like swapping them. Okay, swapping. Yes. I'm not going to take marks off. It's just like, okay, why we put in alphabetical order? It's just a good manner to write things in that way for like with a lot of letters, and also it's easy for yourself to look at things and don't know which one we hasn't write yet, which one we already did. So it's better to write in that way, but not going to lose mark. Yeah.
So if you have a fraction, the numerator is like not negative power, but negative power. You just do the numerator times the.
Sorry, can you say again? Like for example, we have denominator is not negative.
The denominator is negative.
Okay, denominator is negative. Like say h2m to the power of -1,
Yep.
and numerator is like for example n to the power of 5.
Yep.
Okay, so like we still write a fraction here, and n to the power of 5 we can still stay here, and then the negative h to the power of 2 will go up, and m to the power of 1 will go up, which means the denominator just left with a 1. So it's just no fraction, it's just like a number like this. So similar idea for example 16 here. Okay, if you can look at question 17. Okay, if you can look at question 17. So, question 17. If you have something that everything get powered by a negative, okay, it's not like inside negative, it's like everything powered by negative. What you can do is the negative sign will flip the fraction. Okay, will flip the fraction. So that one will just become a 4 over 5 then to the power of 1. That is just a 4 over 5. Okay, you can deal with the negative first. The negative just flip the fraction it connect with. And then here's the negative. What I'll do is 3 over x then to the power of 2. Yeah, you expand it. You can expand it. Well, better expand. So it's 9 over x squared. So So this negative will just flip the fraction b over a and then to the power of 1, that's just b over a. Okay, before I start the second type, I just want to write one question. You can write somewhere like for this question and try to calculate that form. Actually, I should be able to find that question here. No, I don't have that here, so I'll just write one for you. So as we have 5s r to the power of 3 over 15 r to the power of negative 2 s to the power of, let's make that negative 1, s to the power of 4 to the power of 2. Okay, can you calculate the simplest version for me for that question? S to the power of minus 1 times r and then everything to the power of 3, and 15 times r to the power of negative 2 times s to the power of 4 and then that to the power of 2. I want positive index only. Okay, positive index only, and then simplify anything you can simplify. Give you 2 minutes to think about that question. This is a very similar question to like 2016 year 9 or year 10 test on indices answers, and that question, when I remember I marked that question, it just like almost everyone got it wrong. Almost everyone got it wrong because there's a lot of negative, a lot of number and power, and when they deal with it, like it's very hard to get the right answer. 5? Numerator, yeah. Yeah, everything needs to, like, it's a times b times c to the power of 3. So a to the power of 3, b to the power of 3, and c to the power of 3. Yes. I think that question is even harder. They divide something as well. I think there's something divided by something like that. Just make it complex. All the calculation will be the same. But they just like make it a little bit complex. Say you can put the negative like from the numerator to denominator, denominator back to numerator. That's when the question is really easy. Okay, it's not that complex. So what you can do here is, first of all, we need to correctly expand everything. Okay, correctly expand everything. So this step will give me 5 to the power of 3. Okay, times everything clearly. S to the power of negative 3 and R to the power of 3. Okay, over. Look carefully, this 15 is not in the bracket. If it's not in the bracket, it hasn't been squared. So you just have a 15 here. Okay, just a 15 here, not the 15 squared. Times r to the power of negative 4. Okay, r to the power of negative 4. Times s to the power of 8. Okay, you times all the power together. Okay, just write it clear first. Okay, don't worry about anything else. Just expand it, write it clear. Times the reciprocal. Okay, reciprocal is just to simply flip them. That's s to the power of 4. r to the power of negative 1 times s to the power of negative 1. Yes? And because it's a times, right? It's a times. I can just times that like this, right? Just times the numerator times the denominator. Yes? That's a times.
Doesn't it change into a positive? Yeah.
What changed to positive?
Like R to the power.
No, you times the reciprocal. You just reciprocal it. It hasn't changed at all.
Change to positive. You have to flip it back.
Can't you just like
Yeah, you need to go back.
can't you like times it on the outside of the brackets and then flip it? And then that will be the
Yeah, you can flip it, but no. Okay. Confusion here. Okay, the first mistake we find, like what you make wrong. So times the reciprocal is just simply means you flip the number. You're not changing anything. You just flip it. You just times a over b to b over a. Okay, so just flip it. So when you flip it, you will times expand it. You expand it. So the bottom, sorry, times wrong way. So you s to the power 4, and then that's times the reciprocal. Okay, that's the reciprocal. I don't care about whether it's negative or positive. I don't care anything. I just want to flip it first. So I'll expand it here. That's r to the power of negative 1 and s to the power of negative 1. That's s to the power of 4. Okay, what I will do here is magic now. So I'm not going to flip it. It's like up and down. Like it's just too annoying because we have so many r's, so many s. We have so many numbers. Like you may make mistake very easily. So what I'll do, I'll deal with the number first. Okay, I'll deal with the number first. You can see we have 3, 5 here. That down to 2, 5, and that can become a 3. That's the easiest bit we can do. Okay, so this equals to 25 over 3. Done. We have 2 more letters, S and R. So we go R first. Okay. On the top is times relationship. On the bottom is divide relationship. I just look at the pure power. So the first one we got r to the power of 3. So that's a 3. Times r to the power of negative 1. I will plus the power by negative 1. Same base, the power will be add. Okay, times you add them. And then look at the bottom. You have divide by r to the power of negative 4. I will minus negative 4. That's it. A to the power of n divided by b to the power of m is a to the power of n minus m. You just subtract the power. I don't care the power is negative or positive. I just do it. And I will see later in the end. I want to see the result. I want to combine them first and then see the result. So similarly, we can do with the s. S we have negative 3. We keep it as negative 3. We will plus this negative 1. Okay, plus negative 1. And then we divide as 8, so we minus 8, and then we divide by 4, we minus 4. Yes? It's better than flip it and then do it. You still need to combine that all together. Why not just add immediately or subtract immediately? So that's 25 over 3. What we have is 3 minus 1 is 2. 2 plus 4 is a 6. That's r to the power of 6. And the s. S is, well, that's a negative 4 and a negative 12, negative 16. Yes, negative 16. So therefore, the numerator will be 25r to the power of 6 over 3s to the power of 16.
Yeah, I'm right.
Anyone got the same thing? Good. 2. S 25r to the power of 6 over 3s to the power of 16. Okay, we spent about 10 minutes on this question and we got 2 get right. Which I just want to show you is very hard to do index calculations. You need to use some tips to help yourself, like which can make your life a little bit easier. You use that method. You don't flip it like a lot of times and then trying to combine them. You just combine them all together and see what you will get in the end. You just have 2 variables here, which is easy to deal with. Yes. Calculations. Well, there will be 1 or 2 questions like that. Yep. Yes.
be a bad question. Plus 15 on the equal SK.
Yeah?
Wait, how do you know when to take the brackets?
You always expand it first. Like,
So, wait, I wrote down 15 plus 15 ST.
no, this 15 is all times relationship. It's not like, if there's a plus in the middle, you will times the 15 with both numbers. But it's a 15 times something. What you do with is only the something here. You're not going to do anything with the 15 again, like to the second number. So if it's a plus in between, you may like 15 times that plus 15 times that, not times. Okay. One last thing I want to talk about is there's a special question, and that will be in the test as well. Is you want to solve equations like that. Okay. If two number wants to be the same, they need to have the same base and they need to have the same power. Like for power questions, they need to have the same base and they need to have the same power. Let's have a look at the first one. Negative 0.5 is a half. Okay, it's a half to the power of x equals to 2. So a half and 2, they are relative. Okay, so they can become each other. So how a half can become 2? Yes, I can. When I flip it, I can. No, think about power. Don't think about times something. To the power of negative 1? Yeah. So it's 2 to the power of negative 1 will become half. So we have the same base as 2 now, but with a different power. Like a half was changed into a form of 2. That's 2 to the power of negative x, and the right hand side is 2 to the power of 1. So they have the same base now. You need to equalize the power. Okay, you need to equalize the power. So the power will be the same, and x equals to negative 1. That's how you solve this type. Okay, so you need to make everything to fraction form first. Compare the base. I want to achieve the same base. How I can do that? And then I will equalize the power. Just show another one because it's a new type. Well, 0.75. Who knows what is the simplest version for the fraction of 0.75? 3/4. So that's 3 times 2 to the power of 2x equals to 3/4. Well, that 3, can you see that 3 is not a power, like without any power. It's just a number times with that equation. So I'll divide 3 on both sides. Divide 3 on both sides. So times a third on both sides. You have a quarter on the right hand side. How? Well, a quarter equals to 2 to the power of what? A quarter equals to 2 to the power of what? Negative 2. Yeah. You can also see a quarter is 1 over 2 to the power of 2 because it's the reciprocal. The power become negative, so it's 2 to the power of negative 2. So 2 to the power of x equals to 2 to the power of negative 2. So 2x equals to negative 2, x will be negative 1. Okay, show you one more like this one. Okay, on this side, well, you can see 8 and you can see 2 to the power of something. Okay, 8, if I put into a power, like what you will put, like on right hand side. What do you change? 8 will change to 2 to the power of 3. How about the other side then? That's 1 over. Yeah, negative x, because it's the reciprocal, so that's negative x. So negative x equals to 3, x will be minus 3. Okay, for this classwork, okay, I want you to complete the last row here. You don't need to complete the questions before that page. You don't need to complete page 12 and 11 and 10. Okay, you don't need to do 9, 10, 11, 12. You don't need to do those questions. You will do your homework, like the scheme of work, because some questions is from the textbook. I don't want you to redo the question. So 9, 10, 11, 12, you don't need to do that. But you need to complete the last row here. Okay, the last row here. You need to do that question for me. 3 questions. And then tomorrow lesson. Okay, I will go through scientific notation tomorrow, and I'll have a lot of time left. And then Friday, I'll give you as a revision lesson. You can go to do some of your homework. So you have 1.5 lesson to do your homework. Okay, so I'll go some scientific notation, and then you do the practice.
Okay.
Not next week, the week after.